Now you're watching the educational channel on YouTube. Structural formulas of organic molecules. The molecular formula, such as C2H6O, tells how many atoms there are, or atoms there are in that molecule. But it is true that more than one possible molecule can have this molecular formula, where we know that most of the time C will always have 4 bonds. C carbon will always have 4 bonds, and nitrogen will always have 3 bonds with 1 lone pair, and O, oxygen, will always have 2 bonds with 2 lone pairs. We can see the examples of ethanol and dimethyl ether as an example that they both have C2H6O as their molecular formula. But their properties are quite different. As an example, they have boiling point of 78 degrees Celsius for ethanol and negative 24 degrees Celsius for dimethyl ether. So in this case, when they have same molecular formula, we call them isomers. And isomers can either be constitutional isomers, and constitutional isomers are sometimes called structural isomers, and stereoisomers. Constitutional isomers have same molecular formula but different connectivity. That, as a simple example, ethanol and dimethyl ether is a constitutional isomers. Another example could be, let's say we have so both molecules are propane at the moment. But let me raise one hydrogen here and another hydrogen there and replace with OH. Then now this molecule has OH connected to the second carbon, where this OH is connected to the first carbon. So this molecule, the first molecule, will be named 2-propanol, and this molecule will be 1-propanol, or just propanol. And they are considered as constitutional isomers because they have different connectivity with same molecular formula, they will both be C3H 1, 2, 3, 4, 5, 6, 7, 8, and O. Or one propanol will also have C3H8O as a molecular formula. So let's go back to this ethanol and dimethyl ether example. That ethanol has COH with that as a Lewis structure, or dimethyl ether has O in the middle. Again, they have same molecular form, or they have same molecular formula, but their constitutions or the connectivities are different. So this is going to be considered as a constitutional isomers. So going back to our alkane examples, or I'm going to name it isomeric alkanes, and we'll mainly talk about the butanes. CH4 methane has only one type of possible structure, so methane does not have any isomer. Or C2H6 ethane and C3H8 propane also does not have any structural isomers. But butane has isomer that N-butane, it's a 4 carbons joined continuous chain molecule. A regular butane has CH3, CH2, CH2, CH3 that has a boiling point of negative 0.4 degrees Celsius and melting point of negative 109 degrees Celsius, and it has a linear chain, as you see, where there is a isobutane that has C in the middle that is connected by 3 other C. So it's a 4 carbon molecule, and each carbon has CH3, and the middle C has another H because it must have 4 connectivity. So they both have molecular formula of C4H10 and C4H10. Now isobutane can be abbreviated with CH3 CH, and it has a boiling point of negative 10.2 degrees Celsius, which is lower than 0.4 degrees Celsius, and melting point of negative 160.9 degrees Celsius, which is also lower than negative 139 degrees Celsius of N-butane. Bonding in N-butane and isobutane continues the theme begin with methane, ethane, and propane. And all the carbons here have sp3 hybridized, and all bonds are pi bonds. And that is also same to isobutane. All the bonds from the carbon are in sp3 hybridized. So the general relation holds for all alkanes regardless of the number of carbons they have.